Alright, so in this video we'll be looking at quotient rule. Alright, so let's look at these three questions on quotient rule. So now for quotient rule, when we have y is equal to u over v, we are saying that the derivative of y, dy dx, is equal to v du dx minus u dv dx over x squared, right? Over x squared. This is for quotient rule. Do not mix the formula for product and quotient. For quotient rule, there's a minus here, and v du dx comes before u dv dx. For product rule, it does not really matter because it's plus. So whether you are adding, because you are adding, it does not really matter. But this one you are subtracting. So you take it like this now. If you have 5 minus 2, it gives you 3, right? But if you have 2 minus 5, it gives you minus 3. So that's where the problem is, right? That's where the problem is. So if you use u minus v, you will be getting a wrong answer, right? But because it's plus, if you do 2 plus 5, you get 7. If you do 5 plus 2, you get 7. Still the same thing, right? That's why product rule does not matter how you arrange it. But for quotient rule, it matters, right? So that's v must come before u. Just keep that at the back of your mind. V before u. V du dx minus u the v dx all over x squared. So now let's go to question 1. Remember, we solved this question when we were doing basic integration and basic differentiation, where we turned this to x is power minus 1, and then our final answer was minus 1 times x is power minus 2, and then we had minus 1 over x squared, or we have minus x is power minus 2. Either of this is correct. So let's just put it by this side, minus 1 over x squared. So using quotient rule, we are supposed to get that answer, right? Quotient rule is used when you have division, when something is dividing something over something, right? Product rule is when something is multiplied by something, u multiplied by v, right? So for this question 1, where y is equal to 1 over x, we're going to say that u is 1 and v is x, right? So we are saying u is equal to 1 and v is equal to x. So now what do we need? We need du dx and dv dx. So let's find that. So du dx will be equal to 0 because it's just 1. Then dv dx will be equal to 1. So now let's apply our formula and solve. So v is what? V is x multiplied by du dx, which is 0, minus u is what? 1, multiplied by dv dx is also 1, right? Over v squared. What's v squared? V is x, so we're having x squared. So 0 times x will give us 0. So we have 0 minus 1 times 1 over x squared. And this is what? Minus 1 over x. So you can see exactly the same answer, right? Exactly the same answer. But if you have something like this, I guess using the normal basic one is faster. But yes, this one also works. You can also be very fast with this. So it just depends on the question. It depends on the question. The question will determine which one will be faster. Right, something like this now. We have 2x plus 1. Now we are saying this is u and this is v. You can also use product rule for this, but you have to change it to a form that is product rule, right? Because product rule is something times something. But this one I can change it to product rule form. Something like this. I can say x plus 2 multiplied by 2x plus 1 raised to power minus 1. Right? Raised to power minus 1, because minus 1, according to laws of indices, x is power minus 1 equals to 1 over x. So this one we also change to 1 over 2x plus 1, and when I do it, it's going to change back to this one that I have here, right? And once it's like this is, I can now use product rule form. I will still get the same answer, right? Just to prove that you get the same answer, I'm going to solve using product rule and solve using quotient rule, right? But let me just solve using quotient rule. For something like this, it's just best to just use quotient rule. But okay, so we have u to be equal to x plus 2 and our v to be equal to 2x plus 1. So I have du dx to be equal to 1, dv dx to be equal to 2. Now let's apply our formula, dy dx. Let me just put the formula here. So we have v du dx minus u dv dx over x squared. So now the v is what? V is 2x plus 1. Then our du dx is 1. We have minus our u, which is x plus 2. Our dv dx is 2. Then everything over x squared, that will be 2x plus 1 squared. Right? So this is going to give us 2x plus 1 minus, here we're going to be having 2x plus 4 in bracket over 2x plus 1 squared. Should I multiply it fully? No, let's just leave it. So 2x plus 1 squared, right? 2x plus 1 squared. So this one is going to be 2x plus 1 minus 2x minus 4, because we have minus here. Minus times 2 is minus 2x. Minus times plus 4 is minus 4, right? Over, what do we have? We have 2x plus 1 squared, right? So then we are going to have 2x will cancel out 2x. We have 1 minus 4. So that will be minus 3 over 2x plus 1 squared. So this is our final answer. So let me just put it somewhere here. So we have minus 3 over 2x plus 1 all squared. So let me just clean this. Let's now use product rule to solve, because we have changed it to a form that we can use product rule, right? We're supposed to get the same answer. So using product rule now, so we have y to be equal to x plus 2, then we have 2x plus 1 raised to the power minus 1. So we're going to say u is equal to x plus 2, and we're going to say v is equal to 2x plus 1 raised to the power of minus 1, right? So our du dx will be equal to 1. But here our dv dx is not straightforward, right? Because we have this. So before we do this, before we do dv dx, we're going to first say that b, because we have d use u, so we're going to say b is equal to 2x plus 1. So that means our v is equal to b raised to the power minus 1. So that means our dv dx will be equal to dv the what? B db multiplied by db dx here, dx, because if db cancels db, we have dv over dx left, right? So now let's find dv db. This is v and b. So if we're looking for db, is going to be minus b raised to the power minus 2, right? Because here we're having minus 1 multiplied by 1, we have minus 1 times b raised to the power minus 1 minus 1, that will be minus 2. Now let's find db dx, which is this, and that is just going to be equal to 2. So dv dx will be equal to dv db, which is minus b raised to the power minus 2. So let's just say minus 1 over b squared. We are changing this to this form, then multiplied by 2. So this will be minus 2 over b squared. And what is b squared? We have minus 2. B is what? B is 2x plus 1 squared. So we're having this now. So now let us apply. So let's apply our product rule formula, and then we can solve. Let's apply our product rule formula. So I'm just going to clean this and just write only this minus 2 over 2 x, 2 plus 1 raised to the power x. So we're having dv over dx to be equal to minus 2 over 2x plus 1 raised to the power minus, raised to the power 2. Raised to the power 2. So now applying our product rule formula, our product rule formula is u dv dx plus v du dx, right? So our u is what? X plus 2 multiply with dv dx. dv dx is minus 2 over 2x plus 1 everything squared. Then we have plus our v, which is 2x plus 1 raised to the power of minus 1 multiplied by our du dx, which is just 1, right? So now we're having this, we're going to be having this. Let's multiply this. So that should be x plus 1 multiplied by minus 2 everything over 2x plus 1 squared. You can see this one is looking longer, so that's why there are formulas for every single one of them. So this will be 2x plus 1, right? So let me just clean the top. So that we have more space. You can pause the video at any point if you want to, right? So here now we're going to change this one to just one fraction. So our denominator is going to be 2x plus 1 squared. So 2x plus 1 squared divided by 2x plus 1 squared, get 1. Then multiplied by this. This one is going to give us x minus 2x minus 2, right? Minus 2x minus 2. So we're having 2x minus 2. Then we have plus, then 2x squared plus 1. 2x plus 1 squared divided by 2x plus 1 is going to give us 2x plus 1. Then we'll multiply it by 1. So we have 2x plus 1, right? So now let's go. I hope I'm not making any mistakes. So let's go. So we're having here, we're going to be having, this one is going to cancel out this. So we're going to be having minus 2 plus 1 over 2x plus 1 squared. So it's either I made a mistake with this one, that I have minus 3, because this one would give me minus 1 over 2x plus 1 squared. So probably I made a mistake when I was computing this, but I've cleaned it, so I can't locate where the mistake is. But you can see that they look very similar. It's just probably an error I made. So using any method, you should probably get an answer. But you can see that this second one is longer, but you will still get your correct answer if you do it well. So I just advise that you use the quotient rule. Just use your quotient rule because it is easier. The formula is already given. It is easier and you just get your answer very straightforward. Then we have the number 3. Number 3, we have y to be equal to 1 minus 2x over x plus 2. So here we have y equals to u over v, and then we're going to find the u dx, which will be equal to minus 2, and we have the v dx will be equal to 1. So here we're going to solve for dy dx, which is equal to v du dx minus u dv dx, everything over v squared. So dy over dx will be equal to our v, which is x plus 2, multiplied by du dx, which is minus 2. Then we have minus our u, which is 1 minus 2x, multiplied by dv dx, which is 1. Then everything here is going to be over v squared, which is x plus 2. Then we have all squared. Then we have, let me do this. So here we have minus 2x minus 4, multiplying this. Then this is minus into the bracket of my 1 minus 2x. It's better you put brackets so that when you will expand the brackets, you do not make a mistake and you can't put plus where you are not supposed to put plus. Right? So here we're going to be having minus 2x minus 4. Minus 4. Then here I have minus times plus, that will be minus 1. Minus times minus is plus 2x over x plus 2 square. So now let's simplify this. This minus 2x will cancel this. So here we have minus 5 over x plus 2 squared. Minus 5 over x plus 2 squared. And this is our final answer.